they do it for me, because then they'll do it for
It was okay when we reciprocally position our applicants.
We're here. Great. Thank you very much. Good morning, everyone. To all of those who are here in the room and those of you who are watching virtually, welcome to EHA 2022. It's really very, very exciting. And I think I speak for all of us to be here together again and to be able to have this hybrid congress in such a beautiful city. I'm Antonio Almeida. I'm a hematologist in Lisbon in Portugal, and I'm president-elect of EHA. I'll be taking over from Elizabeth McIntyre in June next year. And before we go on to the very exciting abstracts we've selected as really groundbreaking and so important to be able to bring out to the general public, I'd like to say a couple of words about EHA and about the Congress. So this is our first hybrid Congress. As you know, we had to have a very sort of fast-track entrance into the virtual world in 2020 after the whole world shut down in March and our Congress was due to be presential in Frankfurt in June. And I must say the world joined us, and we had over 20,000 registrations for the virtual Congress in 2020. 2021 was also a virtual Congress, and this year, with fortunately better control of the pandemic, we now are able to meet here in person, but we also have the whole Congress live streamed for people to be watching at home. In this Congress, we have this one press briefing in which we have selected the most visible abstracts that will have greatest impact, we feel, on society and on what people perceive of hematology. We have 4 hybrid days here in Vienna and, of course, virtually elsewhere. So we started on Thursday with the Industry Day with the Satellite Symposia, Friday, Saturday, and Sunday with the full Congress program. And then we have 3 fully virtual days next week, which are not just repeats of what we've done here, but which will have novel content. So we've really gone to extra lengths to make this hybrid Congress something very innovative and something that is added value and not just an online repetition of what we have here. So all our sessions here are live and live streamed. And some of them is also recorded and will then be released on demand on the 20th of June. And these include mainly the educational sessions and the plenary sessions and the presidential symposia. The other sessions will be live streamed here, so whoever's at home can see them. The thematic days will be over 3 days next week, and they really will focus on specific themes with novel contents for those themes, and these include sort of myeloid disorders, lymphoid disorders, etc., and with the best of what happened here. So it is important for us to realize that the content is different and it is worth watching when we are back home. Some numbers for the Congress. I think it is safe to say that this exceeded all our expectations. We were understandably concerned about having a hybrid Congress. We were concerned about how safe people would feel, about how the pandemic in the world would behave, and how we would be able to travel or not, and be able to be hosted here or not. But the fact of the matter is that we were expecting about between 5,000 to 10,000 presential registrations. We had over 10,000 presential registrations. And obviously, we will have all the numbers at the end of who was actually here, but judging by hotel occupancy, I'm sure you've all noticed that, I think we have a full house. We also have, in addition to those over 10,000 people that are here, we have 5,000 people that have registered for virtual only. And I think this really is changing the paradigm, and this is probably how congresses will be in the future. So we have over 16,000 total registrations. In terms of content, we have also really increased from previous years. We have over 180 scientific sessions, more than 400 faculty members, over 2,200 selected abstracts for presentation, either in oral or poster format. There are 40 oral sessions throughout the 4 days, 200 oral presentations, and 1,400 posters. So there is really a lot of content, a lot of new material, and above all, we can see from the scientific community that EHA is becoming more and more a preferred place to present their original work. And for that, we are really very grateful and very happy to welcome everybody. There is an additional reason for celebration, not only that we are here and we can have coffee and beer after 5, but this is our 30th anniversary. And I'm sure that you've all noticed that we've even changed our nomenclature. We used to be numbering our congresses by the number of the Congress, and then when we got to the 25th Congress, we decided that this was very confusing to have Congress 25 and 20 in 2020, and we decided that the Congresses would have the number of the year, so this is EHA2022 and not EHA27 or 28. But it is a particularly important date of having a 30th anniversary. Hopefully some of you saw in the opening ceremony yesterday how this all started with 4 visionary hematologists. Many of us knew them, and to see how this has grown and has really started to have an impact, a huge impact on the scientific community and on the fabric of Europe is very gratifying. And it's certainly a privilege, I think, for all of us to be able to participate in EHA. Our main aim really is to promote excellence in patient care through promoting research and promoting education in hematology, but also to advocate for hematologists and for hematology. So we are a professional association, but we are not a syndicate. We are really in favor of promoting the profession, the specialty, so that our patients have access to good care through the education and the research that we promote throughout Europe and the world. And this is really our main areas of activity. So through our research pillar, we support mentorship and career development plans through talent accelerator programs, mentorship programs. We connect hematologists and researchers and scientists worldwide to really, through grants, relocation grants, collaborative grants, research grants, to be able to have scientific interaction. On the field of education, we have really totally reimagined and revamped our education platform. Our education was very much meeting-centered congress and smaller meetings, and now we have a very large platform with a lot of education material, with many new formats, taking into account our busy lifestyle nowadays. So really, it is worth visiting and seeing what we do there. And in addition to that, as I said, we advocate for hematology and hematologists to ensure that in every country in Europe, we have this harmonization in education, harmonization in resources, and that we have the best patient care everywhere. We have some new programs which we are very excited about. We had, as you probably know, we have clinical research mentorship, translational research mentorship, which are accelerated programs over a year to help young clinicians and young scientists become researchers. And we have now a new mentorship program, which is computational biology in hematology training. We have done this in collaboration with EMBL and the European Bioinformatics Institute. So we have huge credibility and a lot of interest to bring computational biology into the scene. We also are aware that hematology is not as visible as we would like for many young physicians. And we have started a program called Lighting the Flame, aimed at medical students and young physicians before they choose their specialty training, to make them aware of what hematology is and the potential of being a hematologist. And we will have, for the first time this year, our EHA Research Conference, very much modeled after world-renowned research conferences, in which we will have top-end research presented by top labs in Europe and the world. And next year, here are the dates. June 8th to 11th in Frankfurt will be a hybrid congress again. So it's not Frankfurt virtual conference, it's in Frankfurt and virtual. So it'll be another hybrid conference for next year in Frankfurt. And with this, I'm happy to take any questions, but perhaps I'll let you listen to what you all came here to listen to, which are our selected abstracts for press. And I'd like to invite Dr. Harry Erber to present his first abstract, which is about...
Good morning. I'm Harry Erba from the Duke Cancer Institute in Durham, North Carolina, United States. And it's my honor to present the results of the Quantum First trial, in which quizartinib was added to standard chemotherapy in newly diagnosed FLT3 ITD-positive patients with acute myeloid leukemia. Here are my disclosures. I've received research funding and have served as a consultant to Daiichi Sankyo, the sponsor of the Quantum First clinical trial. The purpose of this study was to evaluate quizartinib, a potent and selective type 2 FLT3 inhibitor, combined with standard induction and consolidation chemotherapy, and continued as a single agent in adult patient ages 18 to 75 years with newly diagnosed FLT3 ITD-positive acute myeloid leukemia. Quantum First is an international randomized quizartinib or placebo added to standard chemotherapy and then continued as a single agent for up to 36 cycles, including following allogeneic stem cell transplantation. The primary endpoint was overall survival, and the primary endpoint was achieved, as you can see here, with an improvement in the median overall survival with the addition of quizartinib to 31.9 months compared to placebo 15.1 months for a hazard ratio of 0.776, which has a two-sided stratified p-value of 0.0324. Almost all patients had treatment-emergent adverse events. The rates of grade 3 or higher treatment-emergent adverse events were similar for both study groups. However, the rates of grade 3 or greater neutropenia were higher in quizartinib-treated patients. Grade 3 or greater QTc prolongation occurred in 2.3% of patients receiving quizartinib, and 0.8% of patients discontinued quizartinib due to QT prolongation. Ventricular arrhythmias events with quizartinib were uncommon. The rates of TEAEs associated with fatal outcomes were 11.3% with quizartinib versus 9.7% for chemotherapy alone, and were mainly due to infections. So in summary, Quantum First showed quizartinib with newly diagnosed FLT3 ITD positive AML. The safety of quizartinib in the trial was consistent with the known safety profile, and no new safety signals were observed. Thank you.
Thank you very much. First of all, I'd like to just thank you. I wonder if there are any questions here. You can also, if you, I think there's a QR code. If you scan the QR code on the screens or at home, I will see the questions here on the screen and I will ask them. So please.
Osterweil with OBR Oncology. We've been hearing about quizartinib for, I think, a decade. I remember hearing about it at, first learning about it at ASH a long time ago. It's still in development. Why is it taking so long, and why are these data better than what we've heard previously?
Thank you for that question. So you're exactly right. We all remember AC220, and the drug has had several sponsors along the way. I think there are a number of answers to that question. We've clearly been excited about quizartinib as a type 2 and second generation drug. It is highly selective against FLT3 and the next tyrosine kinase that comes close in terms of effectiveness or selectivity is KIT. Otherwise, it's really well selected to those two tyrosine kinases. It has had a long development history. You are exactly right. And I think this stems from the early development with a previous sponsor of quizartinib, where the dose of the drug was escalated very rapidly through dose levels. The PK and, importantly, the pharmacodynamic studies of quizartinib, it turned out at much lower doses. In fact, the first few dose levels, we were seeing responses, and we were hitting that target with over 85% efficiency in a plasma inhibitory assay. And so we had to go back to the drawing board, and the studies had to be redone with different sponsors of the drug, including Astellas, who was developing another FLT3 inhibitor at the same time, and now Daiichi Sankyo. So it has had a long development history. I'll remind you, however, that there was a prior study showing a survival benefit with quizartinib compared to chemotherapy in patients with relapsed refractory acute myeloid leukemia with FLT3 ITD mutation. That's the Quantum R study. And in fact, that study did lead to regulatory approval of quizartinib in Japan. So it has been a long time coming. The obvious question that you are raising is, well, we know that we have midostaurin also for this population of patients, and how will a practitioner choose? Well, this is not a head-to-head comparison, obviously, and that was due to the fact that midostaurin was approved in the United States after this study was launched, and then slowly approved across the globe after that, and still in some countries not yet approved. So clinicians will have to make that determination on their own. I will say what's different about our study is that in this study, we focused on the patients that have the worst prognosis, those with a FLT3 ITD mutation, as opposed to midostaurin, where they had both TKD and ITD mutation. And in fact, if you look at the hazard ratio in the New England Journal paper, the hazard ratio was lowest in favor of midostaurin for the TKD mutated patients. Of course, the study lost power to look at differences. So we're quite excited about what we've seen here in terms of survival data, and at the presidential session later today, I hope to show you data that supports the activity of quizartinib in that set of patients.
Okay, great, thank you.
Thank you.
Can I perhaps just ask a very brief question? I mean, obviously you'll be showing more data in the presidential symposium. I don't want to steal your thunder, but so you use quizartinib followed by maintenance. Do you have data on, you have immediate side effects, but on quality of life and of how these patients tolerate this drug long term?
Yeah, excellent question, because one of the distinguishing features of Quantum First from the ratified trial that led to midostaurin approval is that we continued this therapy for 3 years, as opposed to in the ratified trial, it was continued as 1 year. Part of that decision was from the steering committee that Richard Schlenk and I co-chaired, where we decided that longer duration of maintenance therapy might be very important, especially when we looked at the ratified trial. When the maintenance was stopped, there was this abrupt relapse rate that we all saw. It was presented by Dick Larson at one of the congresses in the United States. And so we continued for 3 years. The important question of any maintenance or continued therapy is the tolerability of that in patients who've undergone intensive therapy and may have already been cured of their disease. We don't have all of that data yet. I could tell you that we did collect quality of life data. We have the safety data. I will not be presenting that subset of patients at this Congress, but I look forward to the disclosure of that data in the future. Very important question.
Thank you very much. Are there any more questions? If not, in the interest of time, thank you very much. Thank you for coming today and submitting your work to EHA. And I'd like to ask Professor Michael Lubert from the University of Freiburg to present his abstract, 10-day decitabine versus conventional chemotherapy followed by allograft stem cell transplant in over 60-year-olds with AML. This is results in an academic trial. And once again, very privileged to have this presented at EHA. Thank you very much, Michael.
Yes, thank you very much for giving me the opportunity to present our data here. It's an honor. My name is Michael Lubert. I'm a hematologist from Freiburg, Germany, and will be presenting the results of the study just mentioned, 10-day decitabine versus conventional chemotherapy followed by allografting in AML patients aged 60 and older. And this is an intergroup study of the ERTC leukemia group, CELG, GEMEMA, and German MDS study group. These are my disclosures. And what's the purpose of the research? Older, medically fit AML patients still represent a highly unmet clinical need, because even if they receive standard intensive chemotherapy, resistance is a major issue. So the 5-year overall survival until now is less than 20%. Very often no successful bridging to the curative approach, i.e. allogeneic stem cell transplantation, is difficult or not successful. So the idea was to introduce DNA hypomethylating agents into this group of fit AML patients. You know that HMAs as monotherapy represent a milder AML treatment approved for medically non-fit AML patients, but alone obviously is not curative. So the purpose of the study to compare an extended decitabine HMA monotherapy 10 days to standard induction chemotherapy as 2 bridges to allografting in fit older AML patients. So this is the design of the study. 606 AML patients aged 60 years and older and fit for intensive chemotherapy were randomized. Half the patients received induction with daunorubicin and cytarabine, 3+7. 303 patients received HMA monotherapy, initially 10 days decitabine, down-dosed to 5 days, depending on the response. In both arms, patients were strongly encouraged to move on to allografting. No decitabine maintenance was allowed in the standard arm. However, for those patients not receiving allografting in the decitabine arm, continued maintenance treatment was possible. The study question will we achieve longer or similar survival with a milder treatment, and will we observe reduced toxicity? And as mentioned, this is a multi-center trial in 8 European countries. The groups I've already mentioned. Apart from myself, Dr. Gerwin Hults from Groningen and Dr. Pierre Weiermans from the Netherlands served as coordinators of the study, which was supported by the educational grant from Janssen. Coming to the results, we observed similar overall survival in the entire cohort with a hazard ratio of 1.04 and a 4-year overall survival of 26 to 30%, and you see a plateau building here. Not shown is a similar outcome in terms of survival from transplant, with a 4-year survival of 47%. We did observe fewer toxicities with decitabine compared to chemotherapy, which supported the long clinical impression of a different toxicity profile. So here, from left to right, you see the 4 most frequent toxicities: blood and lymphatic disorders, infections, changes in laboratory investigations, and gastrointestinal disorders. And you can readily see that 3 out of these 4 major toxicities were less pronounced with decitabine than with chemotherapy. And this was most marked for the gastrointestinal disorders, which were reduced by 2/3 with decitabine compared to standard chemotherapy. Notably, less time in the hospital was spent with decitabine. We observed an average reduction of hospitalizations by 20%. So, to conclude, decitabine provides a better tolerated alternative to aggressive chemotherapy in older fit patients, AML patients, with similar transplant rates on protocol and subsequent transplant of 52% in both arms. We saw similar survival with a hazard ratio of 1.04 and about 30% survival at 4 years, fewer toxicities, shorter hospitalizations, and better quality of life. Thank you, and I'm happy to take questions.
Thank you very much, Professor Lubert. I don't know if there are any questions here. Perhaps I could just ask for a comment, because this is really a question that all of us who treat elderly patients with AML have had for a long time, is whether these patients who are fit for chemotherapy, whether hypomethylating agents is a good option. In general, we have always said that hypomethylating agents are an option for those who are not transplant candidates. And here you seem to be shifting the paradigm and allowing that as a preparation for transplant. Could you comment on that and see how do you think that will change not only what we do, but also the quality of life of patients with AML?
So the rationale behind using a palliative treatment before transplant was obviously that we hope to lead more patients to this point than with aggressive chemotherapy. And whereas overall the transplant rates were similar, in patients 70 and older, we saw an increase in the transplant rate by 1/3 with decitabine compared to standard chemotherapy. So in these patients in this age group, and often with adverse cytogenetics, there seems really to be a benefit to combine the non-curative treatment with the subsequent curative approach. In young patients, 60 to 64, and those with NPM1 mutations, where the CR rate was higher, I will show it this afternoon, CR rate was higher, the benefit was more on the side of standard induction chemotherapy as opposed to decitabine.
Thank you. Certainly very important results which will have, I'm sure, a huge impact on what we do in our day-to-day life in our centers. And I cannot highlight enough the enormous collaborative effort that this study is, and that is really commendable to have such an international collaborative effort to have a big study. Congratulations.
Thank you again.
Thank you very much. And I think, so we'll move on to our third abstract. Dr. Carlos Fernandez de la Rea from Barcelona, is going to present an abstract entitled The Efficacy of AR. Carlos, thank you very much for submitting it to EHA.
Good morning. Thank you so much, Professor Almeida. We have real safety of ARI2H, that is an academic BCMA-directed CAR T cells for patients with refractory relapsed myeloma. I'm Carlos Fernández de la Rea from Hospital Clinic in Barcelona. I am here on behalf of all the Spanish researchers in this project. Here you can see my conflicts of interest. We have developed our own protected against BCMA with a 4-1BB as co-stimulatory molecule. After our results in vivo and in vitro, we decided to explore in a clinical trial and neurological complications, as well as efficacy in terms of overall response in this population of patients with refractory myeloma. Thus, we know that they don't have, even the prognosis has improved, centered in Spain. We coordinated and produced the viral vector in Barcelona. CAR T cells were produced in 2 facilities, in Pamplona and in Barcelona, and together all the 5 centers recruited the patients, performed apheresis, and treated homes. The patients were with a median 4 previous line of treatment. They were all younger than 75 years old. And one of the particular ideas, after we have learned in our previous CAR T for CD19 malignancy, this is approved for exceptional use in Spain, ARI1, it was to fractionate the first dose of 3 million of CAR T cell in three bags, and a second dose, that is the completely new, a second dose of other 3 million of CAR T cells after at least 4 months of the first infusion in patients. All the patients showed some degree of response. That means at least partial response. 63% of the patients achieved a complete remission, and 93% a very good partial response or better. That was associated with a 96 and 92% of negative minimal residual disease in bone marrow by next generation flow at days 28 and 100. We see in terms of extramedullary disease, we see that also all but 1 patient with plasmacytoma responded to this therapy. We have a median follow-up on 1.5 years. And at that time, 53% of the patients are alive and without progression, and almost 3/4 of the patients are alive after this 18 months. In terms of safety, we see mild CRS, mild immune effects in 90% of the cases, but we didn't see any grade 3 or grade 4 CRS, and we don't have any case of neurotoxicity, acute or late. In conclusion, ARI2H production is fast and feasible. It's 11 days of our time of production. Patients achieve deep and sustained response with low-grade toxicity. We are also to mention in the afternoon the potential impact of the second dose. We think that this academic humanized CAR T against BCMA will be a promising therapy for patients with relapsed refractory myeloma. With this kind of academic, I always want to recognize the work of these 5 centers that are participating in Spain, and our patients and their families, and to all the team in my institution that consider as a priority the development of these strategies for the treatment of our patients. Thank you. I'm glad to take questions.
Thank you very much. Very exciting development. Please.
Hi, Nancy Melville with Medscape Medical News. Is there an existing FDA-approved CAR T-cell therapy for multiple myeloma? And how would this add to or improve upon that?
Yes, we have already two drugs, not two CAR T-cell approved in Europe, ide-cel and cilta-cel. And they have impressive results in heavily treated patients. But we know that we don't have any, at least, for example, in Spain, we don't have any option now for treating patients with either ide-cel or cilta-cel because we don't have reimbursement or possibility of production. And that is the reality in the majority of patients in Europe. I think that as many options that we can have with efficacy and safety as we have with these results, I think that it's going to be an improvement in the survival and also, I think, in the quality of life of our patients. I think that this efficacy is, I think that is comparable at least to one of the no inferior, even superior to one of the results with the commercial ones, and we have a safety profile that I think is very convenient for our patients.
Thanks.
Any other questions? Can I just again ask for a comment? Because this is really very exciting in such a difficult disease where we know that these relapsed and refractory patients have a very, very poor prognosis. To have such an impressive response rate that is quite durable in many patients from what you've shown. How do you see this moving forward in terms of both clearly being academically produced, the availability is different and perhaps easier, but also in terms of moving up lines of therapy. Do you see this being used earlier in the stage of the disease to produce longer remissions at an earlier stage, giving its efficacy?
Yes, we are now recruiting a second cohort of 30 patients, and we are very lucky that we have more than 17 patients already fused in the second cohort. You know that in Spain, we are very fast in terms of recruiting patients in clinical trials, at least in myeloma, and because of our previous network. And I think that the idea was to convert the result and to try to gain some kind of approval for the treatment of our patients. To move to another indication will be fantastic. For example, other patients that they don't have options, so many options for the treatment, even in early lines and early relapses. For example, patients with AL amyloidosis, or we have treated one patient outside the clinical trial, or even primary plasma cell leukemia. There's also a disease with a very poor survival now. And I think that we are, for example, in our trial, we consider after 2 previous lines of treatment. The approval in US is after, for example, is after 4 lines of treatment. We think that when the patients are refractory to lenalidomide and daratumumab as our patients, the options with a real impact in the survival of patients are not so convenient right now.
Thank you. And just one more brief question. Your study was centered in Spain, and you do have a very efficient and very collaborative network, which I'm sure is the envy of many countries, especially mine. Could I just ask, how do you see the possibility of this moving beyond Spain? So, this production that you have in Barcelona, can this move beyond and be exported, so to say, and be expanded for access to other countries, which would be other patients, of course, which would be very interesting?
Yes, probably that will be a fantastic mid-term goal, and we have received some proposal, and we're evaluating all the, all the technical, logistic aspects, but that will be fantastic to offer this treatment to patients across Europe.
Great. Thank you very much, Carlos.
Thank you.
Thank you for presenting this at EHA at this meeting. And our next abstract will be presented by Dr. Michael Wang from the MD Anderson Institute of Cancer Center in Houston. And this abstract was presented in part at ASCO 2022. The primary results from the phase 3 SHINE study of ibrutinib in combination with bendamustine and rituximab maintenance as first-line treatment for older patients with mantle cell lymphoma. Thank you very much for submitting this data to EHA, and we're looking forward to hearing it. Thank you.
Good morning, ladies and gentlemen. On behalf of my colleagues, It is my great pleasure to present the primary results of the double-blind, placebo-controlled phase 3 SHINE clinical trial in mantle cell lymphoma. I'm Michael Wang from the University of MD Anderson Cancer Center. Here are my disclosures. Mantle cell lymphoma, as we know, is a rare but distinct subtype of B-cell malignancy. And the older patients with the newly diagnosed mantle cell lymphoma are usually treated by chemoimmunotherapies, the most common one being bendamustine rituximab. Everybody knows that bendamustine originated from Europe. The rituximab maintenance after BR was also proved to be effective to prolong failure-free survival or progression-free survival in 2 independent studies. Ibrutinib is the oral first-in-class BTK inhibitor that has transformed the care of relapsed mantle cell lymphoma. And ibrutinib is especially effective when we use it at the first relapse. The ibrutinib plus bendamustine rituximab was proved to be effective and safe in a phase 1b clinical trial. With all those rationale and background, we designed the SHINE clinical trial. In this trial, we enrolled previously untreated patients at the age of 65 or older. As you can see in the experimental arm in blue, we included the BR for 6 cycles with arm maintenance, plus ibrutinib until progression or tolerance. As shown in green, in the placebo arm, we included the BR for 6 cycles with arm maintenance, plus placebo until progressive disease or intolerance. The primary endpoint of this phase 3 clinical trial was progression-free survival in the ITT population. The primary endpoint of this study, PFS, was met. In other words, our SHINE clinical trial is a positive study because it successfully met its primary endpoint. Our trial showed that the ibrutinib with the BR plus arm maintenance showed a significant progression-free survival improvement. As you can see, the median PFS was 80.6 months in the experimental arm versus 52.9 months in the placebo arm. The hazard ratio was 0.75, and those are statistically significant. The 2 curves separated early because the benefit was separated early, clearly, and the benefit remained durable throughout the 7-year follow-up period of time. If we express all those times PFS instead of months into years, with a median follow-up of 7 years, the median PFS was prolonged by a net of 2.3 years because it was 6.7 versus 4.4 years. This is a very significant 50% improvement compared with the placebo arm. The safety profile was consistent with the new profiles of ibrutinib and bendamustine rituximab. And here we show the common treatment adverse AEs, or TAEs, at 20% or higher. As you can see, the first-line neutropenia was the most common TAEs in either arms and accounted for around 50% in each arm. Rash and pneumonia was 10% higher in the ibrutinib arm. Diarrhea and anemia was higher in the ibrutinib arm. In conclusion, SHINE is the first phase 3 trial showing that ibrutinib in combination with chemoimmunotherapy is a highly effective first-line therapy for older patients with mantle cell lymphoma. The median PFS with the ibrutinib arm was 6.7 years. This is the longest PFS arm ever published in this population. There is a statistically significant and clinically meaningful net 2.3-year advantage in terms of PFS, favoring the ibrutinib arm. This is substantially longer than the currently used chemoimmunotherapies, which is usually about 1.5 to 3.5 years. The safety profile was within expectation and was consistent with the new profiles of ibrutinib and bendamustine rituximab. In conclusion, the first-line therapy with ibrutinib in combination with bendamustine, rituximab, and our maintenance sets a new benchmark for patients with mantle cell lymphoma who are 83 sites around in 28 countries. And we thank you for coming to join us.
Thank you very much, Dr. Wang. Very exciting results, and as you say, really sets up a new standard for benchmark for treating these patients with such a poor prognosis. There are any questions? Oh, 2 questions. Great. Oh, no.
Yes. Hi, Neil Osterwell from OBR Oncology. I remember, I think it was 9 years ago when you presented at ASH and how excited you were about the ibrutinib, the initial ibrutinib data. In fact, it was an infectious enthusiasm. Are there other BTK inhibitors that now coming along that you would look at in the same combination with bendamustine?
I totally recall that 9 years ago in San Diego at ASH, I presented the primary results of ibrutinib alone, and you were right. There was within 15 minutes of presentation, there were 3 standing ovations. But now I'm glad to present the phase 3 clinical trial. This is kind of from phase 1, phase 2, in the phase 3, completing the life cycle of this drug. Yes, there are other BTK inhibitors. Now we know there are 3 kinds of BTK inhibitors. In the first category is the covalent irreversible BTK inhibitors such as ibrutinib, acalabrutinib, zanubrutinib, orelabrutinib, and a few others. The second is the reversible BTK inhibitors that is non-covalently binds to BTK, such as pirtobrutinib, tenorbrutinib. So those pirtobrutinib has already been shown to be effective in preliminary results, and I'm sure this drug will coming along just fine. The third category is the newest BTK degrader. The degraders are also exciting because it will just degrade the target, right? So of course, what's going to be the side effect? How effective it will be? Will it work after the previous 2 categories, resistant BTK inhibitors? Those are very, very interesting. But I think you really meant versus any other FDA-approved agents. But there was a comparison with ibrutinib with zanubrutinib in Waldenstrom's in the phase 3 head-to-head study. And there's also another study in CLL compared with ibrutinib with the acalabrutinib. But in all those trials, the efficacies are similar, but the toxicities differ. And some of the toxicities, like headache, would be higher in the acalabrutinib arm, and in zanubrutinib, there were more neutropenia. So, but atrial fibrillation was higher in the ibrutinib. So there's efficacies, to my opinion, after spending 10 years on BTK inhibitors, they're similar. But the toxicities, we have to know them well and individualize the therapy to each patient according to their comorbidities and their profile, their preference.
Great, thanks.
Yes.
Great, thank you very much. I think in the interest of time, I'm going to the next speaker, but it's very exciting, and thank you for presenting this at EHA. So the next abstract will be presented by Dr. Pedro Aguilar Garrido, and it is RBPS dysregulation causes hypernucleoli and ribosome gain of function driving bone marrow failure. He's from the Centro Nacional de Investigaciones Oncológicas in Madrid, in Spain. Thank you very much for presenting this at EHA, and looking forward to it.
First of all, I'd like to... So I'm Pedro Aguilar Garrido, and I'm working at the Hematological Malignancies Clinical Research Unit between the Spanish National Cancer Research Center and the Hospital 12 de Octubre in Madrid. So I'm going to talk a little bit about how RNA binding protein dysregulation could lead to a situation which is called bone marrow failure. So I have no potential conflict of interest. So as part of my research, we've got 2 different objectives. The first one is to study specific proteins, which are known as RBPs. and their implication in hematological malignancies. Some of these RBPs play a key role in the production of some of the hematological cells in a specific tissue known as bone marrow. So alterations in this type of molecules could lead to hematological malignancies. And in particular, we're studying a protein which is called HNRMPK. The second objective is to discover new targets to treat this type of hematological malignancies, such as HNRMPK as a new target. So we know from our previous lab studies that HNRMPK could act as a tumor suppressor or an oncogene, depending on the hematological malignancy. So finding inhibitors for HNRMPK is a necessity for this type of pathologies. So we know that alterations in RBPs have an impact and could lead to a bone marrow failure. So we were wondering if alterations in HNRMPK expression could lead to the same situation and pathologies. For that, we use cell models and mouse which overexpress this protein, trying to find possible alterations. And we found that there was an impaired protein generation and senescence-like phenotypes in our models. So what we found in our models, in cells, the overexpression of this protein leads to a situation which is called nuclear stress, which is generated by an impair in protein generation and in ribosome biogenesis, leading to a senescence-like phenotypes. And in mouse, we've seen that HNRMPK upregulation leads to an accelerated aging. And apart from all of the signs of aging, the bone marrow of these animals is not working properly. So there's an exhaustion of blood stem cells, and all the cell lineages are not properly generated. So in conclusions, we hypothesize that the upregulation of this protein leads to nuclear stress, leads also to senescence-like phenotypes, and there's an increased protein production. So inside the cell, there's a lot of proteins which are not degraded well, leading to a toxic situation, which also contributes to generate this nuclear stress. These alterations are commonly found in some diseases, such as myelodysplastic syndromes, or pathologies of the ribosome, such as the rarely Diamond-Blackfan anemia or Schwarzman-Diamond syndrome. So that's everything. Thank you, everyone, for listening to me. I'll be happy to take any question.
Thank you very much. It's very exciting to see novel pathophysiology pathways to explain our diseases. Are there any questions? Thank you.
Annette Brindle from BioWorld. Can you tell me a little bit about what this protein binds? So it binds RNA, but which RNAs?
Yeah, this type of proteins binds RNA, DNA, and proteins, okay. And it functions like a stocking platform. So we know that it binds a lot of types of pre-mRNAs involved in all types of pathways, not only the ones that are alterated in these pathologies, but also a lot of functions of the cell. So it's basically a protein which translates mRNAs from the nucleus to the cytosol to be translated into proteins. So there's a lot of mRNAs involved in cell physiology.
Do you have any sense of how it malfunctions when it causes hematological malignancies? Is it overexpressed?
In humans?
Yes.
We know that mutations in this protein can cause AML, but there's a lot of neurological disorders as well, with a lot of bone malformations and this type of pathologies, but there's not a protein that is really studied, so there is not a lot of information about this type of alterations in humans.
Thank you.
Thank you.
there any other questions? Perhaps I could just ask you, because this seems like a very fundamental process in the cell. Do you know that if this, or will you be looking to see if this mechanism is present beyond bone marrow failure syndromes in other tumors or other diseases, including solid tumors? Do you know anything about that?
Yeah, we know that this protein is involved in on another solid tumors. We know that depends on the alterations. It's related to poor prognosis or good prognosis, such as in pancreatic cancers. And we'd like to know what's happening in hematological malignancy, so that's the reason we are studying this protein.
Great. Thank you very much. Very exciting. Thank you very much. Very good to have this at EHA. Our next abstract will be presented by Dr. Barbara Eichhorst from the University of Cologne. It was one of the late-breaking abstracts, and I will just briefly highlight that we had 45 late-breaking abstracts of exceptional quality this year. So the ones that are selected are really, really very important studies or results. This is time-limited venetoclax obinutuzumab plus or minus ibrutinib being superior to chemoimmunotherapy in frontline CLL. So this is the PFS co-primary endpoint of the randomized phase 3 Gaia CLL13 trial. Thank you very much for coming to present this today and presenting it at EHA at the late-breaking abstracts.
Thank you very much, particularly to the EHA board and scientific committee for selecting this as late breaker. I'm really truly honored to present that on behalf of my colleagues. We were a research consortium of 6 study groups in Europe and Israel, including 11 countries in Europe working on this clinical trial. Here are my disclosures. And just as a short introduction for those who don't treat CLL patients daily, so when patients achieve advanced stage, our treatment decision in Europe, at least, is guided, as shown here, by the EHA guidelines according to genetic risk factors as TP53 operation, mutational status, but also to the age and fitness of the patients. And as you can see, for elderly or unfit patients, we have the option between targeted treatments, including long-term treatment with BTK inhibitor, as well as time-limited treatment with the BCL2 inhibitor, venetoclax, in combination with obinutuzumab, based for the latter one on data from the CL14 trial in this elderly patient population. We do not yet have data in a randomized phase 3 trial for the fit patients on venetoclax plus obinutuzumab, and therefore we treat those patients in many countries in Europe either still with chemoimmunotherapy when they have a favorable karyotype, or favorable IGBH status, or with continuous treatment with BTK inhibitors. And therefore, we as a research consortium in Europe wanted to address the question within this 4-arm randomized trial in fit patients who were selected by a fitness score as well as normal creatinine clearance between the standard chemoimmunotherapy with FCR or BR, and due to that all patients were centrally screened for TP53 mutational operation and were then excluded, or 3 different arms, all of them containing 12 months of treatment with venetoclax. And the study has 2 co-primary endpoints with an alpha split to 2.5%. The first endpoint was already met last year. That was the rate of undetectable MRD at month 15 in the peripheral blood measured by flow between venetoclax, obinutuzumab, and chemoimmunotherapy. And we will present here now the second co-primary endpoint, the PFS interim analysis for a triple combination combining venetoclax, obinutuzumab, plus ibrutinib, given also at least for 12 months with a possible extension up to 36 months. And there was also a 4th arm, venetoclax plus rituximab, included, which was also allowed to be analyzed according to a statistical hierarchical ranking. So overall, 920 patients were included, and now after follow-up time of 38.8 months, we see the interim PFS analysis here that with the black curve, the triple combination venetoclax, obinutuzumab plus ibrutinib was clearly superior to chemoimmunotherapy with FCR for the younger patients or BR for the elderly patients who were fit, with a hazard ratio of 0.32. Also, the venetoclax obinutuzumab therapy was clearly superior with a hazard ratio of 0.42, but venetoclax plus rituximab was not superior. So it depends also on the antibody which you combine to the venetoclax treatment. Looking at the two major subgroups in CLL, patients with mutated and unmutated IGVH status, on the right-hand side, we see again that particularly prognosis is favorable for patients with mutated IGVH status, where there's not such a big difference between in blue chemoimmunotherapy and the targeted agents, but we see a huge difference, particularly for patients with unmutated IGVH status. With respect to the side effects, shown here all CTC grade C or higher side effects in 5% of the patients. There were no major difference, particularly not between the two arms containing venetoclax plus obinutuzumab, with the exception of higher rates of infections and febrile neutropenia with the triple combination as well as with the chemoimmunotherapy. With that, I would like to summarize the results of the study. So time-limited targeted therapy with venetoclax plus obinutuzumab with ibrutinib or without ibrutinib is superior to chemoimmunotherapy with respect to PFS, also with respect to undetectable MRD rates. In particular, patients with unmutated IGVH status benefit from this targeted therapy, and higher infection rates were seen with chemoimmunotherapy in the triple combination. And the question with respect to the head-to-head comparison of the triple arm versus the doublet arm, what is the additional benefit of ibrutinib? We will be able to analyze that next year with the next follow-up. Thank you very much, and I'm happy to take questions.
Thank you very much. Thank you for submitting and presenting it this year. And again, I just want to highlight this is a large academic trial with multiple arms, huge collaboration effort, which really goes to answer the questions that we as physicians have. So I think that is a very important point, in addition to your positive results, of course, but a very important point to bring out. Are there any questions? Thank you.
Just a quick question. So to clarify, the benefit is the fixed duration. So is it a shorter course then than the various alternatives?
Correct. So for the alternative would be for CLL patients to give them a BTK inhibitor as continuous treatment forever or until patients stop due to side effects. So BTK inhibitors are very well tolerated, but if you have to take a drug for 3 or 4 years, in particular in these young patients, they may have to take the drug for 10 or 15 years. Even CTC grade 1 and 2 side effects might become a problem after some time. And therefore, the combination we evaluated here was lasting only for 12 months of treatment. It's a type of intensified treatment because BCL2 inhibitors in CLL have shown that they, due to the induction of apoptosis, they are truly able to eradicate the disease, at least to that what we can measure right now. While we know that with the BTK inhibitors, we have a consistent lymphocytosis, so the symptoms are very well controlled. So the benefit for patients, at least that's our aim from this research consortium, is to achieve also not only good treatment of the symptoms of the patients, but also long treatment-free intervals for the patients. And as the data show here, this is obviously possible with this combination.
Okay. And does that also help with resistances?
Yeah, that's one of the key questions, because that's also why, or we know that, for example, with years on treatment on BTK inhibitors, resistance mechanisms may occur, and we have to admit we don't know yet for these targeted treatment combinations with venetoclax. We have some data from the CL14 trial for the elderly patients that at relapse, so far patients have not developed, for example, these BCL2 mutations. So it seems that the majority of the patients was very restricted due to the low number also of relapses. They don't develop resistance mutations when they come off treatment in between.
Great, thanks.
I think another interesting finding, which reinforces something that we have seen in the past, is the fact that obinutuzumab has a different effect to rituximab, even though they are both antibodies against CD20. And do you have some explanation for this? Or, it's something that we've been observing again and again, and it's so comforting or reassuring to see in a head-to-head trial like you've designed.
Yeah, I have to admit we were also surprised about, and we expected a difference, but we did not expect such a large difference, to be honest. Of course, which was also debated in combination with chemotherapy, there is a different dosing, and we give 8 doses of obinutuzumab versus 6 doses of rituximab. So certainly the dose also plays a role, but it might be just to the different acting of mere ADC activity of this antibody. Probably, I assume also due to the much faster clearing of the blood of the CLL cells at the beginning, and therefore also probably better synergism between venetoclax plus the obinutuzumab antibody, maybe also faster immune reconstitution. There are many possible mechanisms for that, I think.
Thank you. But it's certainly very interesting. I think it highlights an important point that not all cats, even though we're cats, have the same color and have the same effect. So I think it is this sort of trial that may even be almost counterintuitive in a way, gives us important indications for questions and answers. So thank you very, very much for presenting this.
Thank you.
Thank you. And now for our final abstract. And now we're moving tack to a benign disease. And I think this really highlights the richness of what we have at EHA in focusing on all aspects of hematology, from basic pathophysiology to different modalities of malignant disease to benign hematological disease. I'd like to invite Professor Franco Locatelli from La Sapienza in Italy, who's going to present, again, a very exciting late-breaking abstract, Efficacy and Safety of Single-Dose CTX001 for Transfusion-Dependent Beta Thalassemia and Severe Sickle Cell Disease. Thank you very much for presenting this at EHA this year.
Thank you very much, Professor Almeida, for your kind introduction, and good morning to everybody. Today, I have the privilege and the pleasure to present on behalf of my co-investigator the results of genome editing targeting BCL11A in patients with either thalassemia or sickle cell disease, and these are my disclosures. Few introductory background remarks just to explain the rationale at the basis of this innovative therapeutic approach. When a child with either thalassemia or sickle cell disease is born, it doesn't initially need a transfusion or develop the symptoms related to the disease. And the reason for this is that the patient benefits from the residual synthesis of hemoglobin F, which is the predominant hemoglobin during the fetal life. And there is also an inherited condition called hereditary persistence of hemoglobin F, in which patients, despite the fact that they can inherit also the thalassemia gene or the sickle cell disease gene, do not develop the clinical signs of birth condition because of this increase hemoglobin F. And we know very well that a molecule coded by a gene located on chromosome 2, namely BCL11A, is responsible for the silencing and the synthesis of the gamma chain. So the line of reasoning at the basis of the approach was that of inactivating this gene through the CRISPR-Cas9 genome editing approach with the specific erythroid-restricted inactivation of the production of BCL11A. After 2 seminal cases published at the end of 2021 in the New England Journal of Medicine, further patients were recruited into 2 trials, namely the CLINTAL 111 or the CLAIM Sickle Cell Disease 121, which are phase 1, 2, and 3 international multi-center open-label single-arm pivotal study of this drug product, formerly known as CTX-001 and now called exa-cel. The primary endpoint for both studies reported in this cartoon, and you can see that the goal was that of estimating the proportion of patients who become transfusion independent if affected by thalassemia or free from severe vaso-occlusive disease if affected by sickle cell disease. And the age range of patients recruited is between 12 and 35 years, and both studies were planned to recruit up to 45 patients, and the enrollment is already completed. Today, I'd like to present the data on all patients who were infused as of February 2022, namely 44 patients with transfusion-dependent thalassemia and 31 affected by sickle cell disease. In terms of efficacy, 42 out of the 44 patients, namely 95%, reached transfusion independence. And the 2 patients who didn't reach transfusion independence had a 75 and 89% reduction in the transfusion volume. And the results are sustained over time. And you see that, for example, in this first patient, the follow-up is even longer than 3 years. In the 31 patients affected by sickle cell disease, the success rate was 100% because all the patients were vaso-occlusive free after exa-cel infusion, with a duration of the follow-up from 2 to 32.3 months. In terms of safety profile, it is consistent with that of busulfan-based myeloablation followed by the infusion of autologous stem cells. In particular, no patients died or developed secondary malignancies or myelodysplastic syndrome. There were 2 patients who developed an SAE, in particular, 1 patient with TDT had 3 severe adverse events related to exa-cel, many occurring in the context of secondary HLH, hemophagocytic lymphohistiocytosis, or macrophage activating syndrome. And the second patient had a delayed recovery of both neutrophil and platelets. So the safety profile of the approach is certainly reassuring for the patients. So in conclusion, the data from these 75 patients with either transfusion-dependent thalassemia or sickle cell disease show that a single dose of exa-cel leads to early increase in hemoglobin F and total hemoglobin that are sustained over time. 95% of patients with TDT stop erythrocyte transfusion, and all the patients with sickle cell disease are free from vaso-occlusive crisis. The safety profile is consistent with that of an autologous transplant preceded by a myeloablation. And thus, we conclude that exa-cel has the potential to be the first CRISPR-Cas9-based therapy to provide a functional cure for patients with thalassemia or sickle cell disease. Thank you again for the opportunity to present the data.
Thank you, Professor Locatelli. I think we'll agree how exciting this is. For many years, we've been looking for cures for these debilitating hereditary diseases, and now that the light is in sight. Are there any questions?
Annette Brindle from BioWorld. So how long, you say it has the potential to be a functional cure. How long would you have to see to say, okay, this patient is cured?
So, the results that we have observed are durable over time. Mm-hmm. No patient who reached transfusion independence or freedom from a severe vaso-occlusive crisis, relapse, and also looking at the persistence of the edited alleles evaluated in both peripheral blood and in the bone marrow. The percentage of the edited allele remains stable over time. Mm-hmm. Thus, we can conclude that the results are durable, and we do not predict that patient should lose the therapeutic benefit from the approach. Okay. Thank you for asking.
Sure. I have more questions if there's time? Okay.
Yep.
So just to clarify for myself, you think that the adverse events were due to the bone marrow conditioning and nothing about the gene editing, is that correct?
Yes, okay. Yes, with the only two patients that I mentioned, one experiencing delayed hematopoietic recovery and the other one developing HLH and ARDS in a situation of profound myelosuppression related to the busulfan administered as preparation to the procedure, because otherwise, without this myeloablation, the therapeutic benefit can be diluted.
Okay. And I have one more question, if you don't mind. So I am from the United States, where it is a poor population that has sickle cell disease and beta thalassemia. I don't know whether that is similar in Europe, but how much does this cost, and how is access going to be?
So thank you for asking, but the negotiation of the cost is something related to the company and just presenting the data. But in any case, before submission to the national or continental, in case of Europe, competent authority, I think that they cannot start to negotiate the price.
Thank you.
Thank you.
Well, thank you very much. I'm sure we'll have a lot more questions when you present this in the symposia. Thank you very much for coming today.
Thank you so much.
Thank you. First of all, I'd like to really reiterate my thanks for your availability to come here this morning, the speakers, and for submitting this work to EHA. I think what we've heard today really shows how, first of all, the EHA is starting to be, and has been, and evermore, the place where researchers, physicians, scientists want to present their data first line. And the richness of what we've seen and heard today, both in terms of benchmarking for diseases, paradigm shifts, novel mechanisms, novel treatments, novel modalities, really shows how important our association is. Really, this is made up of you who submit to us, which I thank you, and of all the critical mass that we have here at the Congress with all the participants and all the attention that we have. And I'd really like to thank all of you from the press and various organizations that come here and listen, because I think this really is of interest not just to the scientific community, but to the whole community as a whole. We really are making groundbreaking discoveries that have an effect on patients' lives, on healthcare systems, and on the way that we treat hematology today. So thank you very much for being here, for asking your questions, and for participating in EHA 2022. And I'm sure that we can have questions afterwards informally if you like. Thank you very much for today.